Awesome.
I
Thank
am
you.
recording, right?
All
Can you hear
right.
me?
So, good morning, everyone, and welcome to this discussion. We're going to talk today about building for FTC with REV Robotics and specifically talk about what we're doing differently with the new REV Control Hub. So, without further ado, we will go ahead and get this puppy moving. Uh, So, my name is Vince Weston. I'm a technical evangelist with Dell Technologies. I am the lead FTA for Georgia, and you're able to reach me as vinceweston@gmail.com. Don't know why there's the barcode sitting up on this. Ignore that QR code up in the corner. I thought I had that deleted off the slide, but that was old from last year. So this is the discussion we're going to have around REV Robotics, around the new REV Control Hub, around some designs for robots, connecting things up, talk about some extra pieces, and away we go. So we'll go through today an overview of some of the robot hardware design. You know, how do you figure out how to build a good design? How do you decide what to do? Talk about the control and expansion hubs, how to connect it all together and make it all work and get you started on the link with the software. There's another class at 4 o'clock on doing the software side of this, so how to do Android Studio programming. And between the two, it's got all the how do you walk through and set everything up and get the hub ready and do all the software with Android Studio and all that stuff. So between these two classes, you should be able to start with a pile of hardware and look at this, follow some instructions online, be ready to go. So we'll talk through all that, and then I'm going to mention some useful parts above and beyond the basics, some from REV, some from things you can find online pretty easily, and give you some ideas on some drivetrain solutions and such. Um, so just to start off, I want to remind you all, since you're building robots to do FTC, you really want to go ahead and read the rules. Every team member and every mentor should read over the game manual part 1 and part 2. You should understand what the rules are, what you're allowed to do, what you should be doing, what you cannot be doing. When you get near the matches, you should read it again. Those of you who've been doing first for multiple years, you may only have to reread game manual part 2 for the specific things for this year. But there are some things that changed in robot content, right? Parts you can use and some other stuff that are in part 1. So it's worth rereading the rules. There's nothing like knowing the rules you're playing under to decide how you want to build your robot and how you're going to approach the game. You should be checking the game forum for updates on a regular basis, and certainly, of course, as you get close to competition. Please remember, robots outside of parameters cannot compete, right? If you are larger than you're supposed to be, if you weigh over 42 pounds, God forbid you shouldn't weigh over 42 pounds. If your motor or servo count is over, right, if you have sharp edges, if you're missing your team member, if you don't have alliance markers, if you're throwing things in games that allow throwing too hard. And just to be clear, all the notes in this are done without knowing what the season is, right? So I haven't seen game manual part 2. I'm just talking as a general, since I've been mentoring first for the last decade, things you need to be thinking about. Some of this is going to be more challenging. Some of you don't have sizing boxes at home. I would suggest that at some point you find a way to get your robot to a sizing box, even if you're doing your competitions for the meets at a home field, because at some point, hopefully by the time we get to the league championships and certainly for state, we plan to be doing all the competitions in person. And at that point, even if you thought you were close because you measured it and you didn't have a sizing box, when you get in that sizing box or fail to get in that sizing box, it could be a problem, right? So, when it comes to designing things, I've seen people build CAD so they take it out to 99.99% of what you're allowed to do that's legal. Give it at least a few millimeters, right? If you don't have 3 to 5 millimeters on each side of your robot as gap in the box, you're pushing it. You're asking for trouble. So give yourself a little gap, build for a little smaller. It's not that tough to stay under 18 inches in each dimension. And yeah, the games always make you stretch, but it's a good thing. So think about that. I'll show you some robots at the end of this, some drivetrain ideas and some robot team numbering and alliance marker stuff and all that can make some of that pretty easy. So we'll talk through that. Design strategy. So one of the things I would encourage you to do is, this is a robot building class. Think about the best way to score points, right? And then think about how do you build the robot to meet those goals. So rather than thinking about what can I build, start with how could I score things? Think about, if you had the parts in your hand, right, and you were walking around the field and maneuvering them in a certain way, what would you do with your hands? How would you move things? And then, is that necessarily the best way? Right? Because robots don't necessarily move the same way humans do. We have these wonderful flexible hands. We have other things. So do you want to do that? Or do you want to do, is there another way to do it? Would you push something? Would you pull something? Would you grab it? What would you do? And then, is there a robot part that you can build that would be a variation on that? We'll talk about some of the printable, flexible material you might try for a 3D printer as well at the end of this. And then once you've figured out, how you want to manipulate things, right, what the arms or whatever are you're going to put on your robot, think about drivability. How does your robot need to drive? Does it have to go over things? Does it have to climb things? Does it have to pull itself up? Or what does it have to do? There's a lot of challenges that happen in each season. You want to be able to do that. So the other thing is, hopefully you will keep things simple and keep them light. A simple robot is easier to maintain. A light robot is easier to pick up and move, but it also means your drivetrain works better. You'll get better speed. You'll be more agile. Fast and reliable consistently will win. Right? Complex, large, slow gets really tough. And if anything breaks, it can take you a long time to fix it. In competition, you've only got a few minutes between matches to fix things. So if you keep it simple, if you keep it light, there's lots of great things you can do. So design overview, we're going to start with the drive base. And again, I've got a couple of things at the end to talk about that. I think there's a separate drive base class this year, but we're going to talk about a few of them in the end of this class anyway. You need a robust frame. It is the core of your robot. It is how all this works. You should be able to take your robot, pick it up 3 or 4 feet off the ground, and just drop it onto the tiles that we practice on. Right? If your robot can't take a 2 or 3 foot drop onto those tiles, odds are you're going to have challenges with how things work. So think about it that way. Think about what you want to do. Oh, I got some questions on the Q&A. All right, all set. I set the Q&A thing up and then I didn't bother to look at it, so now I'm going to pull it a little closer. So anyway, another recommendation is, you don't want the weight of your robot pushing on the internal gears of a motor. What I mean is, if you have a motor mounted on the robot frame and the wheel mounted on the motor axle, and there's nothing else taking the weight of the robot and transferring it to that axle, if you're doing that through the motor, you're likely to break your motors. Right. The axles, if they come out of a motor and go into the wheel, there should be something else the axle is resting on to tie the axle to the frame of your robot, so that the weight of the robot doesn't go into the motor. Right? If you bend an axle, you should, well, some of the new REV ones, you can just pull the axle out and replace it with a new axle. But if you put too much stress on the internal gears, it'll be a mess. So Curtis, I saw your text. Don't worry about doing anything for the voice. I got the Q&A up on a separate screen here. That's why you see me logged in twice. So we're good. Let's see, what else? Manipulator. So plan for your arms and intakes and whatever else. Be thinking about that. The better your drive base does of staying small and out of the way, the easier time you're going to have and the more options you're going to have on how you do your manipulators for the season, right? So just remember that that's available. The sensors are there for your robot to be able to understand and see things. Autonomous is very important in FTC. I know we've got folks who cross over between FTC and FRC, and in FRC, the autonomous program is still human driven and is not that autonomous and not that long. You know, in FTC, it's a serious thing. You know, actually at FLL, it was even harder because the whole thing was hands off when you were driving, right? But in this case, you've got 30 seconds to go do some really cool stuff, but only if your robot knows what's going on. Your robot has the ability to understand things. We'll talk about the built-in sensors. You can use distance sensors, which can be very, very useful for sensing where you are in a field. You've obviously got the motor encoders, which are I find a lot of the motor coders are off by 5 or 10%, which makes it really difficult to do much. I will also point out that there's lots of great ideas on YouTube or on the web where you can see things that folks have done in previous seasons. So John, can you try again? Because other folks are hearing me. Can you try? And Curtis, maybe you can help John. He's having trouble with the audio. So I will also recommend that usually each season there's a folks who do down, I think it's out of Florida, Robot in a Weekend. So in 2 or 3 days, they take the FTC season challenge and they try and build a couple of attachments. You know, some silly drive base, they build a couple of attachments that they think could be cool, and they try and see how much of the goals of what the thing's trying to do they can build in a couple of days. So hopefully that'll help. So yeah, go look at that. Go try sorry, I'm looking at the questions on the side. I'll stop. But look at the Robot in a Weekend. They usually come up with some cool things. It's not to say it's the most effective, but it may help you get some ideas. I will also point out that there are things we do each year that often reuse something from a previous season or that operate in ways that are similar to something that needed to happen in a previous season. And so going back and looking at some of the videos of some of the state championships, some of the other matches, some of those things from super regionals or worlds can give you some really cool ideas of ways that people thought way outside the box for how to solve certain problems. Right? You're not restricted on how far you can go with your videos, and YouTube's got great stuff. All right, pretty simple. Each of the hubs, yeah, this picture is a little old. It has the 2 expansion hubs, and we're flipping one, but it's still a nice picture, right? You've got 4 motor ports on each hub. You've got 6 servo ports, 4 I2C ports for various sensors. You've got analog and digital I/O lanes. You've also got 5-volt power. So for those folks who really want to put LEDs on the bottom of their robot, and I know there's usually a bunch of them, I will point out that if you go on Amazon and other places, you can buy battery-powered LEDs. They come with a little 3 AA battery power pack, which is 4.5 volts. Those are 5-volt LEDs, and you can cut the battery pack off and take a little connector. If you want to play with connectors, I've got some. They sell them for general low-end Arduino and other, little robotic stuff or electronic stuff, right? You can get the little connectors that nicely plug into that 5 volts. You connect that to your LEDs, and now you have a really easy way to power LEDs. There's no JZ chaining. There's no funky electronics. You're just pulling the 5-volt power right off the hub, and it's done, right? And because you have a couple of 5-volt plugs on each of your expansion hubs, if you're going to power LEDs, I will strongly suggest that you use that as the way to do it. So we'll talk more about how some of that works. The hubs have a built-in IMU. If you're not using the IMU to understand your orientation, it's got a gyroscope to tell you where you are, which is great because you can watch the rate of turn and all. More importantly, it's got a compass, right? And it'll tell you it's a magnetic compass, so it doesn't necessarily align to true magnetic north, but it aligns in a constant way for your field. So if you start up your robot and reset your IMU, and you know how you're oriented on the field to begin with, it'll tell you exactly which way you're oriented in the field at all times. So you can use that for coding things like headless driving. Really nice. Again, it's built in, so you get redundant versions if you somehow wanted to try it. Haven't ever had a problem when we've used that in code. It's very reliable. So I strongly suggest you do that. We've got some sample code you can play with. I've got some sample code we can send you if you want to play with that. And you connect these two together and you make it work. So the new control hub, right? This has your built-in robot control hardware. You have no more phone. You have no more phone to control to the expansion hub cable, both of which were a lot of fun, as in complete pains in the tail end. Now, the challenge for that is you also no longer have a camera built into your phone, right? So you are going to need a little webcam. It's got USB ports on the control hub, so you can plug it in, makes all that pretty easy. That also means you can now place your camera where you really want it, because you don't have the diagnostics sitting there on the phone to look at. That also means you don't have the diagnostics on the phone, right? So all the diagnostics you're going to do this year, the folks on the field, the FTAs, cannot go down and look at the phone on the robot because they have nothing but the LED controls coming, the LED light signals coming off the control hub. Right, so everything else is going to be done looking at things from your phone. So your diagnostics and your code need to be that much better. This has a Wi-Fi access point, so you're getting rid of Wi-Fi direct and you're going to use Wi-Fi coming off the control hub. That also means that your laptop can connect to the control hub, so you can update your code from Android Studio. And you can push new code to the robot without connecting a cable to it. So you don't unplug phone, plug phone into laptop, update code, plug it back. All that stuff is gone, right? That also means you can use the debugger in Android Studio and be watching debug breakpoints and doing other things while the robot is running on the field, which gives you a whole different level of diagnostics. So this is really cool stuff. Yes, the hubs are $300. They're awesome. REV was doing a sale earlier this week because of their annual birthday, I guess. So if they're going to do that every year, pay attention, because that was 20% off everything on the site for 3 days. So I picked up a new control hub and some other stuff, but well, it's really cool. If you're going to go build with the REV control hub, last year they had a document you could read that was 15 or 20 pages long. This year they've got a whole web page. Right? It's got 20 or 30 different web pages, each of which has multiple pages of documentation on it and links to all kinds of stuff. So you will want to go read through that and understand it. I'm going to go over high level stuff here and the basics of what you need to do, but you should use that as your way of getting things done and setting things up. And again, some of the software setup for this will be covered in the Android Studio class going on at 4. Connecting things is real simple, right? The XT power cable and the communications cable. If you buy the kit with the control hub, it'll come with a version of those. I will warn you, they're kind of short. When we've been building robots, I'm working with some of the alums who often offer themselves as mentors for teams. So my daughter Becca, Garwacky, Greenie, others. Most of the kids are former Wheeler because my kids went to Wheeler. But we've been working on some things kind of outside of the teams to do some stuff, and they've taken to saying, well, let's use one control hub for the left side of the robot and one for the right, and then the only thing we have running between them is those 2 cables, and we can run all the wiring for all the servos and all the motors and everything else on the different sides of the robot and keep it all nice and separate. It gets us shorter wires and keeps things much cleaner. So something to think about. You got the 2 simple connections, and you now have a built-in management interface. So when you connect your laptop to your control hub, you're going to, again, the control hub will come up, you'll start, you'll grab the Wi-Fi address that it's putting out, and the default password is password, as it'll tell you. And then you go in and change the name for the device, which will also change the address it's broadcasting on, right? But just like with Wi-Fi Direct, you want to name it for team number dash robot controller, and then like an ABC kind of designation beyond if you have multiples. All right, so you log into that. You can set the name, which controls your Wi-Fi. You can set your password, you can set all those kind of things, the Wi-Fi channel, all that stuff. So you can do all that there, and then you're up and running and ready to go. You also want to go down there, something REV has called the hardware client. Download that software. You run the unit will come with a little USB-C connector. Plug that into your laptop and go look at it. REV often has new software. So the REV hub the control hub has its own software operating system. There's also firmware that runs on it and firmware that runs on the expansion hub. So go ahead and get all that downloaded, get it up to date with the plug-in server. You can do some of it wirelessly, but I find it easier just to plug it in and it'll do the automated checks and tell you, yes, it's up to date, or no, you need to go download things. Once you've done that, you connect via Wi-Fi, the management interface. You sometimes have to make sure you specify that it's the 8080, right? That by default, 8080 is where a lot of things go for web management. And the IP address for all the units should default to the 192.168.43.1. Right, so when you connect to that Wi-Fi, you'll be on that channel. It'll give you an IP address for your laptop. You'll connect with this to the management, and then you can go in and do things like upload firmware for the expansion hubs. And then I'll show you how with the phone, you can push the firmware down to your expansion hub, so you're done with that. You don't have to manage anything else. So again, you name it, team number, and for the stuff I'm doing with the alums, we're using a fake team number of 5 nines. Just because nobody's going to have that for real in FTC for a while. And you set up a password. Don't leave your password as password. Don't have people hacking into your hub. At some point, we're going to have a bunch of people in the same room. Be reasonable and set up something secure. Phone pairing. So you need to have version 5 or later. Of course, you should have that. As I talk in the Android Studio class, there is an APK that comes with the software download from GitHub. So don't worry about finding anything in the store, right? You can go to the Google Play Store and do things, but you shouldn't, because there's no way to make sure you're getting the exact right version that you want. Download the code from GitHub for this season, right? You need 5.0 or later to make this stuff work, but there'll be new stuff for this season coming out, I imagine, this next weekend or something. Grab that, download it, take the APK out of that, and use ADB to push that onto your phone, right? Not hard to do. ADB install, right? Then you go into the settings on your driver station, and then you're going to connect it with this. You go into the pairing method, and this is a new thing for working with the REV Control Hub, because before we always use Wi-Fi Direct to talk to the other folks. You're now going to, instead of doing Wi-Fi Direct, your 2 choices within the driver station are either Control Hub or Wi-Fi Direct. So you're going to pick Control Hub. So then it knows that it's going to use the addressing scheme that works with the Control Hub. And then you go into pair with Robot Controller, you pick the name of the Control Hub, and away you go. And it really is that easy to get things connected. Under the advanced settings, so if you go into settings and then into advanced, you will see where you can do the address of your expansion hub, which you want to set normally to 2. You want things to have different numbers, and by default there's an expansion hub built into the control hub. Right? It acts like it has all the same hardware as it does, but it gives itself the expansion hub address of 1, which means your tack-on expansion hub should have an address of 2. If you get in trouble with that, you can take the expansion hub, plug it into a robot control phone, right, and go in through the driver station with that and change the addressing on it. But it should work out. You pick it up, set it to 2, go away. I also recommend that you download the latest firmware. So this is where, if you previously pushed the firmware for on the management page of your control hub, you can upload firmware for the expansion hub. Right, so you go in there, you pick the file, you hit upload. It says, great, I got it. Then through the driver station, you go into the settings advanced, and then you say expansion hub firmware update. And it says, hey, I've got this firmware on the control hub. Do you want me to push it out to all of your expansion hubs? And you say yes, and boom, it goes out, right? So pretty simple. Walk through all this again with the latest code as of yesterday, just to make sure it's all still working that way. So that will get you the latest up-to-date stuff. A couple weeks before you start doing matches, when we start the meets up, you should go do this again, right? Go out there, start up the REV software on your laptop, go check for new versions of the operating system for the control hub, go look for new firmwares for all these things, get all that up to date, because if they're fixing bugs, odds are you want them fixed and you want to download them. All right, so configuring the robot controller, I talked about how to set the name. The easy way to set the name actually is on the primary, but you can go into the settings there, right? And then you can configure your device. You're going to have multiple versions of how you want to do things, create a new configuration, right? And you'll see the hubs and all that stuff. This one's, you'll see hub 1, hub 2. The version I have in the screen capture, I had to 2 and 3. But, you get the ideas, right? And then within that, you have all the different pieces that you can do. So let's walk through configuring a few things here. You want to add some different motors. You go in, you pick the hub, you click on motors. It gives you a list. You click on each motor and you can pick the type. The reason these are different is there are different parameters. Right? There's different gear ratios. There's other things about how the motors act. So you do want to pick the right kind of motor. You don't really need to do much about the naming. So you pick a name and you fill in something simple, right? ABC, whatever. Typing it on the little keyboard on the phone isn't always the easiest. I am going to show you how to download these configurations onto your laptop. So you take the XML file this is generating from the control hub, you download it into your laptop, you can edit it with your favorite laptop editor, as long as you save it as a text file, right? You're editing XML. If you save it in a standard Word document format, it's not going to do you any good, right? It needs to be XML text. But you fill in simple names and the different motor types, and that's the easy way to get all the syntax correct in the XML, and then you can go in and edit the names to your heart content. And it also serves as a backup, right? So that if something happens to your robot, somebody damages your configuration, something accidentally gets deleted, you have a way to go back and get it off your laptop. So then you want to go pick on ports. So we can go talk about servos. You grab a servo port. It's either continuous rotation, right, or standard servo. And then again, add simple names for what you're doing for those. And remember that the REV servos can switch, right? They can be set up as either continuous rotation or standard limited rotation servos, and you can fix the limits on them. And that's what that little programming device is for when you plug it in. So if your servos aren't acting as you expect, make sure that the mode you're picking in here matches what you've set up in the programming for your servo. Digital devices, you got lots of different ports. So they've got the ability to control things like LEDs. So you can buy the REV LED kit and all. Again, you're just putting dumb LEDs out there that you're not controlling in software. You just plug it to the 5-volt on the bottom. But you got the ability to do things like this, configuring sensors, right? Optical disc, touch sensor. I'll talk later in this class about, I'll talk in the software class, I think. About a new sensor that we figured out for rotational positioning of motors, right, to look at where wheels are oriented. And if you add that into the code, right, it actually pops up in some of the drop downs, so you can see, hey, there's this other type of sensor I could be using. So that's pretty cool. And then the I2C sensors, if you're manually adding, your range and your other range sensors, whatever else, there's a whole list of them there, right? And you can pick them and name them and away you go. So, oops. Something just, sorry guys, my window just jumped up on me. So compatibility on this stuff, all the servo ports are 5-volt, right? It works with the old servos we've had. It works with REV servos. It works with a lot of the servos out there in the world. I think it'll even work with some of the things from VEX. Just be careful. So last year I pointed some folks to some linear servos, and the version that the weight limit that I put on that pointed folks, if they search for it, to a 12-volt servo. Any 12-volt servo you use is technically legal in FTC, but it counts as one of your 8 motors. It doesn't count as a servo, and you also have to use it with one of the extra things that REV sells for getting 12-volt power into a servo, but using servo controls. So yeah, don't do that. Right? You've got 8 motors. If you want motors, use motors. Up for all of your 12 servos that are permitted, keep them to 5 volts. And I will talk later about one of the linear ones. So I've got that corrected in these later slides. All the voltage for the encoder ports, the I2C ports, the digital ports, and all that are all 3 volt. If you're using any 5-volt components, right, the things that don't come from REV and some of the other places, you may need to get a 3 to 5-volt converter. REV has them, they're cheap, but if you don't use it, I'm sorry to say you may actually get some feedback, right? So some of the parts will run at 3.3 volts, they just won't run correctly or reliably. So you may not get a hard error, you may just get a whole bunch of funny stuff. So make sure you're using the right voltage, double check that, check your parts requirements, make all that work. There is no support for legacy NXT stuff. Most of you don't even know what I'm talking about. But when we first started doing FTC, we were using some of the Lego parts. It's been a long time, but we don't support for the old Lego sensors. The REV sensors are pretty cheap. Just go get them or find somebody else. There's an Expansion Hub guide that has lots of details on what you can plug in. Like I said, all of that is now kind of superseded in the Control Hub guide, but there's lots of things on there in the old REV expansion guide specifically about how do you wire these things? How do you connect them? How do you get the power right? And if you're doing a 3, or how does that exactly does that work? So that's been a great doc to have. And when we pass these slides out with the presentation, you can easily click on it and go grab those. So one of the things you will find is that you have a config file. I think this one's actually based off of a pair of expansion hubs, not the control and expansion, because I use the same class each year with modifications for new stuff. But the formatting is the same, right? So it's an FTC robot. For those of you who know how to parse XML somewhat with your brain, right? The robot type, and then you have a USB device, and then you have the modules, right? You close it off. The serial number for the device is in here. Just be careful. If you replace the device, the configuration file won't find the new serial number, so you may have to edit that. So just be aware of it. So you're going to see 2 different expansion hubs listed in here. You'll see, you can see servos, whatever. So the reason I suggest that you name things simply on the phone is sometimes typing things on the phone isn't much fun. So you can grab this off of your robot. When you're talking to the control hub, you'll be in Android Studio. Android Studio has a terminal interface that'll put you to basically a command line under Windows that has a set of strings set up for Android Studio. And one of the commands you can run in there is ADB, which is the Android debugger. And so if you look at the orange text down below, to manage the XML file, ADB space pull space, and then the XML file. So everything on your control hub is under /SD-card/first, right? So that's the software card internally where it's keeping all these files. First is obviously where first is putting everything. And then the mod happened when it said, name your configuration. If I named it mine, it would be mine.xml. If you use mixed case, you have to match the case. So if you make it Fred with a capital F, this to be first/Fred with a capital F.xml, right? And then the dot on the end says copy it from there, pull it from the card path that you're typing in to the current directory, right? That'll put it in the default folder at the top level of your Android install. Excuse me, for the Android code that you're working on. So the thing you have open in Android Studio. And then you can push it. So I took mine, I edited it, and then I changed the name to mine-2, right? And I do ADB push mine-2 to /SD-card/first/ and it knows that when it starts with the SD card first, that means put it on the robot, right? So ADB will push and pull the XML file back and forth. Again, it allows you to easily change things, edit names, make all the text match, allows you to have backups of these. It also is really easy when you're doing your code in Android Studio to make sure that the names you're putting in the code match up with the names in the XML file. Because you can open this up in an editor and read it right next to your code and make sure that the 2 go together. And here you can see, different motor types, and you'll also see the IMUs are in here. And we'll talk about some of the other parts you can have when we get into the later in this class and a bunch of stuff in Android Studio. So lots of great stuff there. But one of the most important tricks on this is being able to push and pull these XML files. So other useful parts. That's kind of the highlights of the REV Control Hub. That should be enough to get you started and get it running and be using it like you were last year and give you directions to get to all the code. So there's some other really cool stuff that REV has put out this year or late last year. They built a new motor with modular gearing, right? And so you have the planar gearbox that allows you to select 3-to-1, 4-to-1, 5-to-1 gearing modules and stack them. So you can have a motor that does 1-to-1 and a motor that does 60-to-1, and it's just a matter of stacking pieces. And we've been playing with some of that. We've got some drivetrains we've been playing using 1-to-1, got some using 5-to-1, some using 20 to 30-to-1. But the fact that you don't buy different motors, you just change these out, means that you can design what you need. Some of this started with Velocity Vortex, where we really needed motors or wheels spinning to throw things. We calculated that based on the size of the wheels, we needed them spinning at like 3,600 RPMs. Well, at that point, you needed less than a 20-to-1 gearbox. So help me, Mr. Wizard. Right? These give you that, and it's just a stack of gears, and you can mix and match, and it makes all that really easy. So I have to say I strongly recommend these. Also, if you look at the top there, you'll notice that there's a socket on top that has room for screws, so you could screw a gear directly onto the motor and not have any axles or axle pieces to worry about. But it also does accept the hex axle, and you can shove it down in there, and there's a little set screw on the side, and you're done. That also means if you have an axle, you can just pull the axle out and replace it. Right? This keeps all of the attachment stuff that we'll work on for that little end adapter and everything else out of the gearbox of the motor. So unless you're really burning out motors, those motors will last a really long time for you. In the middle, we've got a wheel here. So REV has this new 90-millimeter wheel, so it's about 3.5 inches in diameter, but it's also almost an inch wide. Lots of traction. It's also set up so that the internal hub, the spokes you see there, are offset to one side. So there's room for things to come inside the wheel to hold it and be screwed together without poking out outside the wheel, but without having to be set right in the middle. So you get a chance to bring the wheel in nice and close to the robot. So anyway, I think it's a pretty cool way to do it. And again, since they've got the hex drive going through the middle, you don't really need screws to drive it. You just need something to hold it on. And they've got some new extrusions. So I've got an example here. The outside edges, the same faces you would have on their old 15 mil extrusion, but now you have a 45 mil wide piece of product that you can use for building frames that has not only stiffness across, but it resists twisting. It allows you to build a frame with a single piece instead of like a pair of rails. And I'll show you some designs we've got at the end for that. And I'm assuming if you all have questions now, you're going to type them in the Q&A. I've got a few more slides I'm going to keep going through. But if you've got questions you want answered, type them in the Q&A. If you've got a long question and you need to be unmuted, if you put that in the Q&A, then Curtis, who's so nicely taking care of us and being my moderator here, can get you unmuted and we can have a voice discussion. REV has some new 3-inch Mecanum wheels. They got ball bearings for each roller, which are really nice. It's metal in the middle, so it's really robust. Again, it's an offset center, so you can have all the screws self-contained. They're really light, so if you're doing Mecanum, it's something to think about. I've seen no end of Mecanum wheels that break. So these look to be really solid and simple and fairly cheap. I mentioned earlier for climbing or other things, there are linear servos that you can use to move. That also works for reaching out and pulling back. Yeah, Chris, you had a note about the slides. We are going to publish these. So again, if you go to Servo City, they offer 5 to 6 volt servos like this. They also offer 12 volt servo. Now, I don't have a copy of this exact servo. I haven't played with it. I did see them when I met with the Servo City guys at Worlds a couple years ago, and they had just announced these. That was like 18 months or so ago. They were new. They were really cool. They call it a light duty thruster, but it's rated for 44 pounds. If your robot's limited to 42 pounds, right, a pair of these doing a vertical lift should be able to pick your robot right up fairly easily, right? I mean, you might do it with one if your robot's really light, but you can certainly do 2 in parallel and go. So it just gives you some interesting options, right? And this has the 140 millimeter stroke, so that's almost 6 inches of movement. And you can amplify that by using strings and angles and other things. So just an interesting idea for a way to move something that's fairly simple. We've had a couple folks look at how to do some things with the linear servos that appears to help a lot. So just something to think about in terms of how you design it. I have it in here because it's not something that people have necessarily thought about before in terms of a servo, but I think you make a difference in how you design some pieces. Wire management is important. You can get the cable chains pretty cheaply on Amazon, right? You can get 15 mil, 25 mil width cable chain and it allows, or they call it energy chain sometimes, and it allows you to have things move. So if you have parts on your robot moving in and out constantly, that can be a very nice way to do that. If you notice on, professional forklifts and on some of the 3D printers and some of the other stuff that moves a lot, even within a lot of the printers that just you have running at home printing on paper. They'll have the cable running in some kind of a cable chain or energy chain to make sure that things go where they're supposed to and cables don't go wandering. Otherwise, if you have several cables going somewhere, like you need to have your power cable and your control cable running across between the two sides of your robot, right? One of these little plastic conduit wraps, you get 100 feet of that stuff for like $5, right? And you wrap it around the cables, and lo and behold, your cables are now nicely managed. And so it gives you a way to do some of those things pretty simply. Always do a grounding strap. Right? If you're playing with REV stuff, especially, you've got the power ports on your two hubs. So you put power into one hub, daisy chain to the other, then you've got an open power port on the second port. You plug this into it, you fasten it to your chassis, everything's grounded. We've seen past instances where robots were not well grounded and they caused issues, sometimes even shorting out with other robots, dealing with static, dealing with other stuff. This will also make sure that if another robot is not well grounded and bumps yours, and you get metal-to-metal contact, so you're transferring the static or even the power, this will help your robot to live through that much better. So it's a $4 part. I can't recommend it strongly enough. Make a real difference in resilience of robots in contact matches. Other ideas. So some of the pictures you see here, so the red and black pictures are from things that were running on robots at Worlds 18 months ago. So the teams had decided they wanted to have some better intakes. So they printed with the flexible, I won't call it PTF, but it prints with basically PLA heat, but it's a flexible material. And the green item you see in the bottom is actually printing on my print. Right? The Wheeler kids use a lot of green in their robots and things, and they designed an intake where they wanted to be playing with the balls, and they decided that 3 intake prongs was better than more, and so lo and behold, you could print this nice flexible thing, and then by choosing the thickness and other things, you can decide how stiff or flexible it is. It's really a pretty cool material to use. So I want to encourage you, rather than just thinking, how do I use a wheel to push something or a wheel to grab something, or everybody's put zip ties on the front of things on different seasons. You can do early, but if you have things that you really want to move, you can make special knobby wheels. You can make grooves. You can make whatever patterns you want on something that fits exactly where you want it to fit. So think about the fact that 3D printing isn't just for hard solids. You can print this soft material and make that work pretty well also. So since nobody has other questions, I'm going to talk through a couple of drivetrain ideas. 18 months ago, when the Wheeler kids went to Worlds, they had this swerve drive that I thought was reasonably cool. So this was based on the REV motors with the sideways output. So if you look carefully, you can see that there's actually wheels standing, the motors vertically inside the wheels. So the motor turns with the wheel and the wheels pivot and away we go. This wasn't a bad design. It's a little tall, but it was fairly flexible and most of the stuff was up and out of the way. And it was a 4-wheel swerve and you could go wherever you wanted. Oh, that was pretty nice. We put some nameplates on the side. You can do it like this. I got some other ideas on the next couple slides, but building a nameplate that makes it easy to attach your Alliance indicator, right? The red square or blue circle, and then the ability to have your power switch there and protected, the ability to connect, have your team number nice and big, have a team name if you want to, however you want to do stuff, right? So again, this is for a pretend 5.9s thing that we're doing just because we're playing around. I'm playing around with some mentors and alums on some drivetrain stuff. So we built a copy of what they were doing, just kind of to have as an example, because then I can take pictures of it and do what I want to, and I don't have to have access to the wheeler room. By the way, you'll also notice on this frame, on each of the corners, there's a ball bearing, right? So if your robot comes up against the wall and needs to drive along the wall, that ball bearing, because the way it's centered, keeps everything about 7 millimeters away from the edge of the actual square frame. So you can run up the wall and slide against the plexi. And if you get to those little notches where the plexiglass changes from piece to piece, the ball bearing will tend to help you glide right past that instead of catching on a corner of a robot on the edge of the plexiglass. So, and then you can see running across on the right-hand picture, you can see the little black tubing routing the wires. So you've got the power and communications for the two REV hubs running across on the top wire, and then wires running down to motors and other things in some of the back shielded pieces. But the wires are all protected and tidied up and out of the way. You'll also notice, by the way, we have alliance markers here that just are through this faceplate that have a little clip on them. We've got some designs for that as well, so glad to share any of this stuff. How are the bumpers attached to the frame? So I gather by that question you mean those the ball bearings that are on the edge. So what we did was we printed a part, actually printed a pair, in this case it's one part that reaches over the ball bearing. So it's got 3 screws on it. It's got one that fits right in the corner that goes through the middle of the ball bearing. And then it's got 2 that go out to the sides that go along the 2 rails in the corner. And so we screw it on from the bottom into that little corner piece that you see, making the corner nice and clean. And so it's a simple printed 3D part. We can show you parts. I'm glad if you want to play with those. We're working on getting a bunch of parts uploaded into Thingiverse. We can put code up on GitHub. So let me know what you all are interested in. Glad to post things. The thing you see on the front in the right-hand picture was last year we played with. What if this thing could grab the foundation that was being built on and go play with it? Just playing around with some ideas. The focus was on the drivetrain and making it do self-driving and such. So, the red and blue. The alliance markers. Actually, the way that we're attaching them, we have a square hole. We slap it in there, and then we've got a little printed clip that clips down the backside. And so, if you look in the pictures here, you can see the blue on the front, especially on the left one. You see the blue on the front, and then on the far side, you can see a bit of blue poking through. So basically, the alliance marker has one square that fits in a hole in the frame and then a smaller wedge piece on the back. And we simply slide a wedge clip into it that holds it in place. To change your alliance marker, you slide the back clip up and pull it off and then just drop the next one on. So we've got a way to make that's basically idiot-proof and easy. And all you need is the right size hole on your robot somewhere, and you can just clip these things in and out in seconds. So we've tried to make this brain dead easy. And again, glad to share the CAD for that or just the STL files, and you can just print them. Right? They're all 3D printable. They're easy. They don't require any support being printed with them. And they're sturdy. They work. They're the right size. Done. It makes all this so much easier. Okay, a couple other robot design ideas. So last season, you can tell I spent a bunch of my time playing with the Wheeler kids. They built a 2-wheel differential swerve. Nobody does more than 2 powered wheels. This is a variation of that. So what we did that was a little different is instead of putting the differential swerve wheels in the middle, we put them on the back side. We're working on how to do this without having the 4. So there were 4 Omni wheels in the Wheeler design. It had the differential swerve drive was in the middle. Omnis were on the corners. When they got up onto the plate in the middle, it kind of got funny. There were a few places where that didn't work so well. So I was working with Becca on some ideas, and Becca said we should move the 2 drive wheels to one side. So technically we call that the back of the robot. So we moved the 2 differential swerve wheels to the back, made those compact modules, and then on the front side to hold the weight up, we put a couple of roller bearings. So you see the little plastic roller ball sitting up in the corner of the slide. The roller ball is cheap. You get them for $1 or $2 a piece. They're made for being used in conveyors. They're rated for a couple hundred pounds. And so we simply screwed that up through some plastic, and lo and behold, we now have something that has at least a ½ inch of clearance, that rolls all over the field. It rolls in any direction and has almost 0 resistance. All right, so because the original ones were metal, these are nylon. They're dirt cheap and easy. So if you look for bolt type 1-inch nylon transfer bearing on Amazon, again, you'll find a bag of 6 of them for like $6 or $8 or something. It's cheap. The other thing was we wanted to know where the wheels were pointed. Yes, we have encoders on the motors. I mentioned earlier I don't trust them. They get off by 5 or 10% pretty easily. So this little device you see on the side is a Grove AS5600 magnetic position sensor. So you take a little magnet and you run it around in a circle below the sensor, and this sensor will tell you where that magnet is in a 0 to 360 degrees. It's a simple little device. It costs about $6. Plugs right into the I2C port, done. It's already 3.3 volts, so there's no conversion needed. So it makes it really easy to add in with this REV stuff. We've written a driver for it. So if you decide you're going to build a wheel that needs a sensor, you can see we've done it here. It comes off that and goes right into the hub. Right. So you can, if you look in the right-hand picture, it's kind of a, well, here, let me show you the zoomed in shot. I think I've got one here. Right. So this is the zoomed in shot of that robot, and you can see on top of each of the two wheels is that positioning sensor. And right below that, there's a magnet. So as the wheel turns around left to right, it's got a pair of motors in it. Right? As the wheel turns left to right, it moves the magnet triggers the sensor tells the hub where it is. Lo and behold, I know exactly where things are. So that's been pretty nice. You'll also notice on the motors that are poking up high, we actually printed a cap for them. So we just 3D printed a cover to snap on top that protects those cables. So the lower motors we didn't bother with, so the cables are kind of exposed. But on the upper one, we printed a cap just so you could cover the motor. And this way, people who turn the robot over to play on the bottom, crush the wires, right? So think about your drivetrain. Think about what you might do. How can you create open space? This one has 10 or 11 inches of open space in the front, both across and depth. So there's room for a whole bunch of additional things you might put in the middle of the robot. And then as a final thought for how you might do a drivetrain, this is the new simplified one. So with the new REV 90 millimeter wheels, we decided to take the swerve, what I just saw a couple slides ago with the 4-wheel swerve, and build a version that only did. Right. So we're literally building a swerve robot that only has 2 wheels, and then it's got the same ball bearings on the other end. This is using that new REV extrusion that I showed you several slides ago, because it's got nice rigidity in multiple directions. Again, still got the ball bearings on the end to roll against the wall, all pre-printed into that. And again, willing to share CAD parts, just let us know what you want. And then we're finishing the drive design. So we're not quite there yet. The motor does work. It will turn. It will make the wheel spin. Andrew Garwacky, who was part of the Wheeler team 2 years ago, he found some really cool stuff for doing swerve with FRC, and said, well, gee, why don't we use this and drive an axle, motor outside, drive an axle down to the wheel and make it work. So we figured out how to do that. So you can see the motor standing vertically there, and a bunch of gears to drive it down into the middle. And then we've set up a worm drive to turn the orientation of the wheel. So that motor powers the gears that actually powers the wheel forward and back. It's a 1-to-1 gear ratio that should send it across the 12-foot field in about 2 seconds. It's a really nice gear ratio. You got to do pretty high gears because of some of the gear ratio angles you've got to have, and the fact that the wheels are only 90 millimeters. Right, so the speed on them isn't going to be high without a low gear ratio to push a lot of speed out of the motor. The other thing that has is the worm drive allows us to turn the wheel. And again, haven't finished it on the robot yet, so no guarantees. But the plan is to use a couple of servos and use a worm so that we don't get the power of the motor into the servos. And with that worm gear, we will turn the orientation of the wheel. So a couple of servos turning a worm lets us orient the wheel any direction we want. We're going to use the same little rotation sensor to decide which direction the wheel's pointing, so we can do multiple 360s. Because since we're using a magnetic sensor, you can have the wheel point any direction you want. You don't have the challenges. Many of the encoders that are available won't do a full 360. And this will do as many 360s as you want. It's an absolute position sensor, and we haven't been able to get it to move, right, in terms of failing. It's always on. It's always showing the right stuff. So that's been awesome. So anyway, here's an idea, right? Some simple small wheels, some nylon pivot balls, the new REV extrusion, go have fun. This is not a trivial thing. I don't recommend starting designing a new drivetrain at the beginning of your season unless you've got a really skilled team. But you can design one and use it in the following season and work on things. You can try lots of stuff. And again, we're willing to share designs that we've been working on, myself and some of these alums who are also mentors. Might be a way to get a new mentor for your team, to have somebody come talk to you and help with some ideas. So 3D printing is your friend, right? This is multiple gears, multiple parts stacked together and working. So lots of great stuff. With that, we are at time. So I'm glad to help you all to talk about more of this. If you want to reach me, you can reach me as vinceweston@gmail. So I hope you found this class useful, and I look forward to talking with you all throughout the season in whatever way we can be helpful. Thank you very much. Curtis, do we have any voice stuff? I'm guessing not.
My mic's
all right,
not
I guess we're
working.
time anyway. Thank you all very much. Have a great day. Enjoy the reveal, and hope you come back and listen to my software discussion at 4 o'clock.